Today we're going to do the application of electrostatics. We're going to do this by using the Triboelectric Series. We have to recognize that different materials have different tendencies, and a tendency is kind of what they tend to do. For example, we've got all these different materials here. That some materials down here have a tendency of losing electrons when rubbed against another material, and some materials have a tendency of holding on or gaining electrons. So some objects have a tendency to give electrons, right? They're givers. And some of them are takers. Some have a tendency of gaining electrons. This is what's called the Triboelectric Series. And up to this point, we have rubbed a rubber balloon. Notice it's on the negative side of the Triboelectric Series. It wants to gain. Rubber material rubbed against cotton, which was a lot of our shirts. When we rub them together, cotton has a tendency to give electrons. And the rubber balloon that we rubbed it upon has a tendency of gaining electrons. They each have different tendencies. What they do with their electrons is their tendency. So let's apply the Triboelectric Series to that. So how do you know what charge of an object is, if it's positive or negative? You could test it against a known charged object to determine what the charge of the unknown object was. For convenience, scientists developed the Triboelectric Series, and that's what we're going to be doing. We're going to be using this. Materials on the positive side, up here, have a greater affinity or tendency to give electrons than those on the negative side. When any two materials are rubbed together through friction, the one which is on the negative side can be expected to pull electrons from the material on the positive side. So we can apply the Triboelectric Series here. So if we rub a rubber balloon, so use a table, right? Use the table to make predictions of the charges for each of these. So a rubber balloon, rubber rubbed against cotton, you're going to find that cotton's going to have a tendency, in this case, of giving up electrons, and the balloon is going to have a tendency of gaining electrons. Rubber balloon against a wool shirt, you can simply find where wool is up here. It's going to be the same effect. Wool's going to give, rubber balloon's going to gain. And you can do these on your own here. You can kind of pause this and check these out yourself. But we're really just applying the Triboelectric Series. So the Triboelectric Series in its entirety is going to tell us what the tendency of objects in the positive and negative when we rub them together, which one's going to give and which one's going to gain. Since materials are commonly neutral, rubbing two objects together relocates valence electrons, transferring from objects on the positive side to the negative side. The materials on the positive side have the greatest tendency to become positively charged due to the loss of valence electrons. And those on the negative side become negatively charged by the addition of electrons. So the greater the distance here, if I were to rub Teflon with, say, rabbit fur, you're going to get a greater amount of electric force, a greater amount of number of electrons that are transferred because they are further distance on the Triboelectric Series. Whereas rubbing wood and paper or cotton, they're not that far apart. So you might only transfer a few or a couple electrons. Hopefully this makes sense.